The challenges of driving business profitability and connecting and synchronizing supply chains continues to demand, as never before, creative thought and purposeful action. Internally, these challenges require companies to develop integrative information technology that can rapidly collect, analyze, and generate information about customers, processes, products, services, markets, and company and partner distribution channels to guide purposeful decision-making. Building a real-time knowledge bank enables the creation of seamless links and the coordination of the capabilities of individual companies, their customers, and their trading partners. Externally, these challenges require companies to deploy information technologies that enable them to architect supply channels that are collaborative, agile, scalable, fast-flow, and web-enabled. The goal is to present customers with a single seamless response to their wants and needs by creating a unique network of value-creating relationships. Connectivity and synchronization at this level require the end of channel information silos and the construction of collaborative, channel-wide communication and information management, directed at a single point: total customer satisfaction. The impact of information connectivity and integration, however, extend beyond merely facilitating internal and operations functions. They provide a launch point for the generation of new sources of products and services, whole new businesses and marketplaces, and radically new forms of competitive advantage. Today's robust information systems enable companies to view internal business information system and interorganizational channel architectures as a fully integrated set of components, as shown in this picture. We will explore those three components in this and next two lectures. Let's start with the enterprise technology architecture. As a principle, it can be stated that the capabilities of a business are directly related to the enabling power of its technology architecture. Simply put, the ability of a company to effectively execute productive functions is in direct proportion to the velocity by which the organization can create, collect, assimilate, access, and transfer information. When seen from a high level, the information technology infrastructure consists of four essential components as illustrated in this picture. The first and central core of computerized information management is the database. The database is the repository of all data that has been captured by users and consists of various categories of information, from numerical values to words to graphics. There are several different types of database. A hierarchical database stores related information according to predefined categories in a tree-like arrangement. A network database is used by a network installation tool to allocate and track network resources. And finally, the most common type is the relational database. The relational database is the model most used in today's software systems. The key feature of this model can be found in the centralization of key master records such as items, customers, and suppliers that can be referenced by multiple software applications without duplication. In addition, besides increased security, flexibility, scalability, and performance, relational databases enable the use of sophisticated data mining toolsets, such as structured query language, SQL, for data reporting and analysis. Since databases store an enormous amount of data, they require a database management system that allows users to create, access, and query the data. The second component of today's technology architecture is networking. A computer network can be defined as two or more computerized devices linked together over a geographical area. Networking permits users to exchange data with each other and to generally share hardware or software connected to the network. The computerized communication devices are connected to either a local area network used for internal networking in a private company, or devices can be connected to a wide area network that is used in a dispersed networking environment such as the Internet. There are several possible variations. An intranet is a proprietary network that only permits people like employees to access information and application software. An extranet is a private network, utilizes the Internet Protocol and the public telecommunication system to permit selected outside business partners to enter part of a proprietary network. And finally, a virtual private network utilizes the public telecommunications infrastructure, the Internet, to access a network through secured entry. The third component of technology architecture is software. Software is a general term used to describe the various kinds of programs that are used to enter, maintain, display, and access the information resident in databases. Without effective software, companies are unable to utilize the knowledge both within their databases and through networking with the business partners. In today's internet and social networking age, software success or failure can have a dramatic impact on the well-being of the company. In addition, information management personnel must be ever vigilant to ensure that the usability of their software systems keeps up with the changes in programming languages and design necessary to ensure compatibility of their information systems with their strategy in dealing with the marketplace. There are basically two types of software: operating system software and application software. Operating system software controls the application software and determines how hardware, devices, and peripherals will work together. The most famous are Microsoft Windows, Mac operating system, and Linux, that are used for personal computer environments. The second type of software is application software. This type is used to perform processing activities such as accounts payables and receivables, payroll, and order entry. Software also provides tools for displaying the database and generating reports. In the past, the development and maintenance of software was a time-consuming, difficult, and expensive process. Today, almost all software is created using a tool called service-oriented architecture. Basically, this enables developers to pick the parts or services they need from installed systems and to assemble them into an application that corresponds to the needs of a specific business process. The principle is simple. Imagine that a programmer has access to every application subroutine not only on their system, but to any application available through the Internet. After importation into a new application, when the program ran only the subroutine would be used and not the original program. The final component of an information technology infrastructure is the actual configuration of hardware, system software, and application software. In the past, system architectures consisted of dumb terminals and peripherals hardwired directly into the computer. Today, most systems architectures utilize powerful personal computers, middleware applications, and communications enablers, like the Internet, to build networks capable of integrating people and knowledge both internally and externally. Now let's continue with the second component of the supply chain management technical architecture, enterprise business architecture. The term enterprise business architecture can have a very wide meaning. It encompasses the components of the firm that are responsible for the performance of ongoing transactions involved in buying, making, and selling products. It also refers to the corporate culture that has evolved over time and drives current and future attitudes, expectations, and value judgments about what is the mission of the company. It consists of the particular configuration of human and computerized resources that accumulate, analyze, and utilize the enterprise's repository of information. And finally, it consists of the core competences of its human resources that breathe life into and serve as the directing instruments of the totality of the firm's business components. Without an effective architecture, an enterprise's evolution to more successful models would cease, and its ability to adapt to change in the face of new business paradigms and technologies would rapidly disintegrate. The foundation of an effective enterprise business architecture resides in the creation of a comprehensive information strategy that directs the organization towards a coherent, integrated environment for managing and delivering information in support of both short-term and long-term objectives and business goals. The effectiveness of a business architecture is the ability of its processes and systems to respond to changing conditions and customer interactions as they occur. Today's business architectures will of course have varying degrees of operational and strategic responsiveness. Regardless of the actual structure, the goal is to improve responsiveness over time and increase the value and effectiveness of the business systems comprising the company's architecture, transforming them into competitive weapons. Managing this evolution requires the utilization of the following fourfold agenda to guide information strategy development and definition, as well as the governance of supporting information infrastructure. Information strategy definition. The information strategy establishes the principles that will guide the organization's efforts to create and exploit their information system databases and application capabilities. The information strategy provides an end-to-end vision for all components constituting the information system structure and is driven by an organization's business strategy and operating framework. The information strategy establishes the culture, nomenclature, and common objectives to assist all levels of users realize the information system vision. Organizationally, the strategy sets the ongoing framework and guiding set of principles to ensure that current and future investments in people, processes, and technologies align and support an agile and flexible information environment. Information definition and governance. Defining the content of a business information repository and its governance is a critical component of an enterprise business architecture. This is a nuts and bolts issue that requires answers to basic questions as to the nature and accuracy of system information, where it is located and how long it is kept, and how does the business access and use it for decision making. Information definition and governance can enhance the quality, availability, and integrity of database information by fostering cross-organizational collaboration and policy making. Effective governance of system data requires establishment of a specific corporate organization whose mission is to define the policies and managing practices of information assets over their life cycle. Information infrastructure. If a business is to leverage their information systems as a competitive advantage, it is essential that they construct and maintain an effective enterprise-level information infrastructure. Anything less results in significant operational inefficiencies associated with data duplication, inaccuracy, and inaccessibility. As detailed in the discussion of the technology architecture, an enterprise information infrastructure framework identifies the technology necessary to establish the database management systems, software, networking toolsets, and the actual configuration of these components into a technology solution governing the functioning of the enterprise. Information structure deployment. The enterprise information architecture must provide a deployment roadmap that defines how the various technology toolsets governing systems management will be configured, maintained, and improved over time. Among the critical tasks constituting the action plan can be found leveraging existing investment in hardware and software, prioritization of technology projects, dates for technology rollout, capabilities required to support and access relevant information, reference to forthcoming business and governance practices, and discussion of future investments in emerging technologies. Most organizations today have some form of information technology strategy, set of governance guidelines, hardware and software infrastructure, and program for continuous information structure improvement and deployment. What differentiates first-in-class from the herd is the ability to address each of the above four components of enterprise business technology simultaneously, while ensuring integration with the third component of the enterprise information business system framework, the enterprise business architecture. We will explore it in the next lecture. Let's continue with the last third component of supply chain management technical infrastructure, enterprise business architecture. The promise of today's integrative information technologies is that it provides for the cross-enterprise unification of databases that can be used in an almost infinite variety of ways to provide a different rich context to every accessing entity. In such a unified enterprise environment, there is no distinction between employee, partner, and customer portals. They are all windows into the same repository of information, differing only in the roles that are defined for each user, the interactions that are associated with each role, and the level of access permitted for each role. Such a vision of enterprise unity requires that all members of the supply chain be closely integrated and their databases and information flows closely synchronized to eliminate distortions and the bullwhip effect in the communication of information. Architecting enterprise structure capable of synchronous information flows requires channel partners to develop and constantly attend to a joint strategy that seeks to utilize the best technology toolsets to realize targeted individual company and supply chain objectives. Such a program involves the following critical processes. Architecting a shared enterprise vision. The development of an information technology strategy in isolation from the challenges of integrating with the channel trading partners is destined to failure. While it is true that the shared vision emanating from inside the organization provides companies with a cohesive force to drive a common direction, focus, and personal and team motivation, strategists must be careful to include the vision of how the internal functions of the company are to fit into a much wider supply chain vision. Such an undertaking requires a comprehensive knowledge of internal and partner core competences, technology capabilities, and commitment to supply chain collaboration. The goal is not only to structure a functional system of cross-channel business, but also to use the framework as method to leverage the entire business ecosystem to discover breakthrough propositions made possible by the common shared information platform. Enterprise business modeling. Once the enterprise supply chain vision and strategy has been completed, companies can then begin the task of establishing the enterprise-facing portion of the business model. The enterprise business model provides a high-level description of the technology integration points connecting each business in the supply chain network. The objective of the model is to detail for the supply chain as a whole the following marketplace dynamics. Target market segment, including expected share, profitability, service goals, customer retention, and new customer acquisition. Products and services, including product line profitability, life cycle management, new product service introduction, and manufacturing strategies. Financial elements, including return on assets management, return on investment, potential revenue growth, and internal productivity cost measurements. Product distribution, including logistics, depth of channel integration, cost structure, levels of automation, and cost management. A critical element in the enterprise model is the information architecture. It is the responsibility of each channel partner's information architects to configure and maintain a repository of computerized process components that enable the desired level of communication and networking among channel members. Enterprise process modeling. Once the enterprise vision and business model have been formulated, the next step is to detail the process model that describes the external processes that govern daily supply chain functions. Developing the process map requires strategists to know precisely which business functions are going to be enterprise processes, what technology infrastructure must be in place, and how the organizational structure should be constructed. The most attractive element about today's integrative information technologies is not the wizardry of technology, but the information it makes available. Information provides companies with a window to reality, and the more accurate and timely, the better businesses are able to make the decisions that will assist them to better service their customers, develop their workforces, invest their resources, control their costs, and remain competitive. While business applications such as ERP, CRM, SRM, Internet-enabled business, and other computerized toolsets remain as the basis for information management, several new developments are reshaping the face of business computing today. Whether it is ERP, customer relationship management, or other software suite, software companies of all flavors can expect today to experience the following range of requirements from prospects before they will purchase any form of software. Technology architecture. As companies look to their application suites to expand interoperability and enterprise integration capabilities, the utilization of technology tool sets such as service-oriented architecture, Java, and Microsoft's .NET framework for web service development is a critical litmus test for today's integrative information technology. These platforms make it easy to develop powerful web application servers that facilitate integration and interoperability with add-on application point solutions. Adaptability. Today's marketplace considers robust toolboxes a requirement. It wants a less built-in structure and a greater focus on company-specific native business processes. Cost. The newer way of software is built on open architectures and therefore requires less expense for hardware, training, and modification. Implementation. While software today is no less rich in functions, system architects have built-in flexible configuration toolsets, portal-type capabilities that enable merger of outside applications, and even pre-configured solutions targeted at specific industries that facilitate adapting standard functions to closely mirror existing business processes. User adoption. Today's new wave of software is easier to use, has less interface clutter, is more focused on native functions, and is more likely to gain rapid user acceptance and validation. Software as a service. The robustness of today's networking technologies have spawned a new industry directed at relieving companies of the cost and organizational burden of implementing cutting-edge software and network building by providing major business system applications and technical infrastructure for a subscription fee. Computer systems, application software, networks, the internet, all are fundamental tools that every business must utilize. Maintaining these tools, however, are normally outside the core competences of most businesses. What software as a service basically does is provide companies with the ability to lease software over a secure internet access network. Often there is little or no upfront investment required by participants. The subscriber does not own, license, or even keep a copy of the software on its in-house system. Rather, the software as a service company hosts the software and the related IT services, including upgrades and maintenance. In addition, the software as a service company can provide the network linking the client's offices, homes, and operating locations to the data center. Finally, the software as a service company provides the licenses, implementation, training, system management, and user support necessary to ensure the subscriber receives the anticipated value. In return, the software as a service company determines payment on a subscription basis for an agreed upon period of time. A new development in software as a service is the concept of cloud computing. While the ultimate definition of cloud computing has yet to be determined, there is little doubt that it represents the next major business shift in the IT industry and business computing. In addition, according to a survey, cloud computing is emerging in conjunction with green IT and sustainability as major corporate strategies. The idea basically is to realize the possibility of enterprise IT organizations meshing seamlessly an internal network cloud of applications with a public cloud, hosted by an integrator that charges on a pay-as-you-go basis. This concept has been defined as a model for enabling convenient on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. The range of enterprise business system applications offered by software as a service companies varies and can range from small companies which specialize in sales and customer relationship applications to SAP and Oracle, which offer their entire suites of software products via the internet. The decision to choose using a software as a service supplier requires companies to seriously think through issues such as business applicability, security, and cost. Companies looking to implement a cloud solution are confronted with several challenges. Foremost is understanding the scope of the business requirements, followed by assessing project return on investment, overcoming a lack of internal expertise, and simply understanding what cloud computing actually does. Wireless technology. Today, the presence of wireless information capture and transmission pervades just about every facet of the supply chain. The use of RFID, Bluetooth, Global Positioning System, GPS, and other technologies working in tandem with cloud computing environments, web portals, and backend systems to track everything from apparel, equipment, and appliances to animals and even people is transforming the information processing capabilities of the supply chain and promising to enable a new dimension of business management. In general, these tool sets for monitoring and tracking can dramatically assist everyday business uses, such as providing supply chains with tracking capabilities, solving or averting problems, and increasing efficiencies. Wireless can be defined in its most rudimentary form as the transmission of data between devices that are not physically connected. A wireless device may be anything from a personal digital assistant (PDA) to a laptop, a two-way pager, a global positioning satellite antenna, or a remote sensor. The data communication can occur at short range using infrared technology, at a wider range using high-speed wireless LANs located on a fixed structure, or globally using satellites. The goal of wireless technology is to provide mobile workers access and input to any database anytime. It enables collaborative information exchange where physical co-location is not feasible. It also assists in tracking, locating, and managing movable assets such as cargo, containers, laboratory equipment, and delivery trucks. By creating network of objects, wireless technologies not only have the ability to exponentially improve the flow of information through the supply chain at the speed of light, they also can provide the intelligence to examine patterns and trends about channel business trends and weaknesses. Probably the most talked about of the wireless devices is radio frequency identification devices. While the technology had been around since the turn of the millennium, it began to gain traction with the announcement by Walmart that their top 100 suppliers had to have RFID labels at the case and pallet level by January 2003. Walmart hoped to use electronic product code tags, which store details about products and transmits them to inventory systems using RFID chips and readers to create a more efficient supply chain. There can be little doubt, however, that as wireless technology expands and matures, it will become an essential building block of supply chain management. Although the RFID-enabled supply chain has not materialized, the technology has enjoyed a wider success in the public sector, particularly government, military, and smart card projects for passports, ID cards, and prepaid transportation cards. Wireless enables a wider audience of participants within the organization and outside in the supply network to bring automation and efficiency to a new range of processes by making information ubiquitous and real-time. While there are still many issues to resolve, wireless technology is destined to have as much of an impact on business and technology architectures as the arrival of the Internet. The successful management of information is the key to business success. Managing information means that companies must find solutions to such questions as the following. What is the information that is needed to effectively automate, informate, and network the organization and its business partners? How is this information to be organized in a meaningful manner? What are the software applications to be deployed that enable people throughout the network to enter, access, and work with the information? How can the network of users ensure that the data is timely and accurate? The answer to these and other questions is the ultimate goal of today's computerized business systems. Realizing this goal requires the application of technology toolsets that automate tasks subject to human or environmental variance, activate new sources of information assisting people to effectively collect, access, and analyze system data, and provide a platform for the close networking of business partners across the supply chain. The 5 basic functions of information systems. At the foundation of every information system reside 5 common functions as they are shown in this figure. Now let's explore each one of them. First one, enterprise database. The foundation data necessary to operate the business is located in the system database. These records are for the most part composed of 2 types of data. The first, static data, consists of core information elements such as customer and supplier masters, item masters, product structures, product costing, warehouse geographically, bills of material and process routings, manufacturing equipment, and channel structures that do not change during the performance of transactions. The second type, variable data, consists of databases such as open order, transaction balance, and accounting, which are impacted through transaction management. Today's computing technologies enable companies to have a single database, relational database, that all departments can use jointly. Furthermore, the advent of connectivity tools like the Internet provide the capability for database networking, where key database files such as forecasts, channel inventories, and open order status can be viewed by users both external as well as internal to the company. Next function, transaction management. Transaction functions enable users to enter and maintain database information and consist of such activities as order entry, inventory balance maintenance, order selection, allocation and shipment, and payables and receivables. Computerized transaction management programs serve several purposes. They provide for the accurate and timely entry and collection of transaction data. They automate difficult and time-consuming record keeping. They enforce rules governing transaction data entry and maintenance, and they enable companies to collect large volumes of information that can in turn be used for business analysis, management control, and strategic planning. The overall goal of transaction management functions is to ensure an accurate record of the firm's day-to-day operations. Management control. The entry of transactions and the compilation of databases are meaningless without defined best practices and performance measurements to guide process flow management and decision making. This function focuses on toolsets that permit developers to create standardized applications, ensuring uniformity across channel businesses and analysts to mine enterprise databases, in an effort to uncover and detail operational and financial measurements relating to such issues as cost, asset management, customer service productivity, and quality. Management control has the following goals: ensuring rationalization of business functions, providing the feedback necessary for the timely reformulation of operations plans and activities, ongoing measurement of the competitive capabilities of the enterprise, and development of plans providing for continuous improvement. A critical function basic to an information system is the ability of planners to utilize a variety of modeling tools to assist in managing simple to increasingly complex processes during decision making. Some of these applications, such as material requirements planning and capacity management, provide mature and easy-to-use applications to simulate the impact of demand on inventories and productive capacities. Other computerized applications assist in the identification, evaluation, and comparison between alternative courses of action, such as vehicle routing and scheduling. Finally, in this area can be found powerful advanced planning systems and supply chain management applications driven by complex mathematical algorithms used to design supply chains, determine plant locations and aggregate demand, and supply data across channel networks. The goal of these functions is to provide planners with the capability to identify and evaluate the best choices from a range of competing alternatives. Strategic planning. The role of strategic planning functions is to provide managers with the capability to construct long-term plans and forecasts used to determine enterprise financial goals, explore strategic business partner alliances, design marketing approaches, and define and develop productive capacities necessary to support product and service requirements. The plans developed in this function provide the basis for management control, decision analysis, and performance, and are used to drive the operations plans executed by transaction functions. The overall goal of strategic planning functions is to provide the enterprise with competitive advantage. While the exact structure of the applications used by today's information systems varies by industry, a base architecture must provide the business with a common database, a suite of relevant transaction programs, reporting and display, some form of simulation and tools for ongoing operations management and control, as well as long-range planning. Principles of system management. Whether the capture of historical data for forecasting or the utilization of inventory transaction balance records, an effective information system requires databases that are of the highest integrity and are easily understood by the user. Here are 7 principles of information system management that are fundamental to an efficiently run business system. Accountability. Without accountability, an information system will quickly spin out of control and lose its ability to provide meaningful information for planning and decision making. Transparency. Transparency means that the system provides the user with answers as to why and how the system requires a particular activity to be performed. Accessibility. Computer systems remove the difficulties surrounding data retrieval by containing programs that provide for quick access and update of critical information, such as order status that span company departments or even databases belonging to trading partners. Data integrity. The usefulness of information technology is directly dependent upon the accuracy and timeliness of its databases. Accuracy can be defined as the degree to which actual physical data corresponds to the same data recorded in the system. Timeliness can be defined as the length of the spatial delay between the moment a transaction occurs and the point in which it is recorded in the system. The speed of data update is critical in providing users with the ability to perform activities in a timely manner. Valid process simulation. If an information system is to provide useful information, the transactional and maintenance programs in the system must work the way the business actually works. In effect, a business application is actually a representation, a simulation of the actual physical action performed during process execution. Flexibility. An information system must provide the users with the capability to perform transactions or manipulate data to meet the needs of both the business and customers and suppliers. And lastly, control. A fundamental benefit of an information system is the ability to control business processes. Applications should provide users with reporting and exception messaging designed to alert them as early as possible to actual or pending out of control processes. Without these basic disciplines in place, it would be virtually impossible to achieve the necessary levels of performance from an information system, regardless of its sophistication and elegance. The fundamental objective of an enterprise business system is to extend the structure and benefits of computer integration and networking to encompass the entire enterprise and the supply chains in which they are intertwined. In practical terms, this means that not just a portion but all business functions from purchasing and inventory control to forecasting and general ledger must be integrated together. The goal is to place all internal enterprise processing, decision-making, and performance measurement in a common database system capable of being maintained and referenced in real time by all company users and selected supply chain partners. The enterprise business system itself is composed of two elements. The first is the hardware, consisting of the computer, input-output devices, and data storage warehousing. And the second element is the software that contains the application programs used for processing transactions, displaying the database, printing reports, management control, and operational and strategic planning. Core functional areas of operations. The enterprise business system is the workhorse of a business and truthfully can be said to constitute the hub or backbone of the enterprise information infrastructure. An effectively implemented and utilized enterprise business system links the different functions of the business, drives continuous improvement and process efficiency and effectiveness, provides the mechanisms to support company strategies, and enables the pursuit of e-business technology. As shown in this figure, an enterprise business system can be described as having two major components: the technical architecture and 8 tightly integrated business modules, one for each of core functions found in a typical business. The technical architecture refers to the hardware configuration, programming languages, graphic presentation, document output capabilities, database designs, and a host of other enablers available in the system. In a wider sense, the technical architecture refers to the choice of how the enterprise business system is assembled. It can be composed of a single homogeneous, fully integrated business software system, or it might be the result of a company's decision to assemble a best-of-breed portfolio, model linking third-party point solutions to a homegrown or previously implemented package solution. The second component of an EBS is the array of 8 possible core business applications that an enterprise might deploy. These applications are described as follows: customer management, manufacturing, procurement, logistics, product data, finance, asset management, and human resources. Depending on the nature of the business, an enterprise may utilize some or all of the modules. For example, the EBS of a manufacturing company that performs distribution functions will have all 8 modules activated. A wholesaler would most likely have all except for manufacturing-related functions. A .com catalog business would most likely have customer management, HR, finance, and perhaps procurement and logistics. Regardless of the business environment, every company will at least have to install customer service, order management, and finance. These base functions would be difficult to outsource without losing corporate integrity. Let's now describe each one of those modules. The first one is customer management. The primary role of this module in an EBS system is to provide availability to the user interface queries that enable order entry, order promising, and open order status maintenance. Order entry and service maintenance are the gateway to the sales and marketing database. Second, this module should provide the data necessary to perform real-time profitability analysis to assist in calculating costs, revenue, and sales volume necessary for effective quotation and ongoing customer maintenance. Third, a well-designed EBS will provide marketers with tools to design sophisticated pricing schemes and discount models. In addition, the software should permit the performance of miscellaneous functions such as order configuration, bonus and commissions, customer delivery schedules, tax management, currency conversion, customer returns, and service and rental. Next function is manufacturing. Functions in this module comprise most of the foundation applications in the suite of modern-day EBS. Originating as a bill of material processor, this module has been enhanced over the decades to include material requirements planning processing, manufacturing order release, work in progress management, cost reporting, and overall shop floor control. A critical integrative aspect is the real-time linkage of demand to supply management, facilitating order to production and work in progress modeling, while promoting real-time available to promise and capable to promise to assist in customer order management. In addition to these basic tools, today's manufacturing model also contains functionality for activities such as inspection, project management, capacity resource management, and the compilation of production statistics. Next one is procurement. In today's business climate, the ability to effectively integrate procurement requirements with a variety of supplier management concepts and technology tools is one of the most important components of an effective EBS. Although much press has been given to web-based business-to-business technologies, basic management of procurement requires a close integration with internal MRP and maintenance, repair and operation supplies systems. Today's EBS contains a robust functionality to facilitate purchase order processing, delivery scheduling, open order tracking, receiving, inspection, and supplier statistics and performance reporting. In addition, detailed request for quotation must be available that ties back to customer demands and extends out to supplier management, negotiation, and pricing capabilities. Next one is logistics. The ability to link in real-time logistic functions to sales, manufacturing, and finance is fundamental to competitive advantage in the 21st century. Today's EBS must provide the mechanism to run the internal supply chain of the business, as well as provide the necessary connectivity with remote trading partners located on the rim of the supply network. Critical tools in the module center on distribution channel configuration, warehouse activity management, channel replenishment planning and distribution order management, and the generation of distribution asset and profitability reporting. Next one, product data. At the core of manufacturing and distribution information systems reside the databases describing the products that the company builds and distributes. Often considered highly proprietary, these databases contain data ranging from engineering descriptions to details concerning costs, sources of acquisition, planning data, and product structure details. Besides obvious uses for inventory and manufacturing planning and shop floor management, these databases are critical for marketing, product lifecycle management analysis and costing, engineering, product introduction, and financial reporting and analysis. Next model is finance. Without a doubt, one of the strong suits of an EBS is its ability to support effective management accounting. In fact, one of the criticisms leveled at EBS is that it is really an accounting system requiring everyone in the business to report on an ongoing basis each transaction they perform with 100% accuracy. Today's financial applications provide for the real-time reporting of all transaction information originating from inventory movement, accounts receivable, accounts payable, taxes, foreign currency, and journal entries occurring within the enterprise. Next, assets. Effective control of a company's fixed assets is essential to ensuring continuous planning of the productive resources necessary to meet competitive strategies. EBS databases in this model center on the establishment of equipment profiles, diagnostics and preventive maintenance activities, and depreciation tracking. And last, human resources. The final model composing a modern EBS is the management of an enterprise human capital. Functions in this area can be broken down into two main areas. The first is concerned with the performance of transaction activities, such as time and attendance reporting, payroll administration, compensation, reimbursable expenses, and recruitment. The second is focused on the creation of database necessary to support employee profiles, skills, and career planning, and employee evaluations and productivity statistics. We will continue with some secondary functional areas of operations in the next lecture. Now let's continue with some secondary functions of the operations. Today's extended EBS is the product of the mergers of the 8 core business functions with the integrative networking capabilities of advanced internet-enabled software applications. Realizing today's requirements for speed, agility, real-time control, and exceptional customer satisfaction means that enterprises must employ a variety of technology applications beyond the core business model that enable the construction of a business architecture that is effective, efficient, purposeful, integrative, and collaborative. The resulting system consisting of a mixture of often disparate non-core EBS technology applications, data collection devices, business-to-business point solutions, and legacy systems must be capable of being disassembled and rapidly reassembled into a single framework that matches the needs of the marketplace. At first sight, the application suites comprising the universe of today's enterprise system appear to be a maze of software products: ERP, customer relationship management, supply chain management, electronic data interchange, and other technology acronyms litters current business literature and impart an impression of incoherency, comprehensible only to a select club of industry analysts and techies. This figure here is an attempt to assemble the core EBS functions and the possible components of today's extended business system into a coherent model. As can be seen, the model is divided into three distinct regions of software products: core EBS, middleware, and connectivity-enabling applications. Now let's describe each one of those regions. The 8 core functions of EBS stand at the center of today's integrative information business solution. As described in details in the previous lecture, an EBS acts as the hub or backbone of an enterprise transaction and information management functions. Using the core functional software applications as a foundation, today's extended EBSs have been gradually converging with one standalone point solutions and web-based applications to provide enhanced functionality and networking capabilities not available in the past. Electronic data interchange. The definition, advantages, and drawbacks of electronic data interchange were discussed in the previous lectures. In summary, it refers to the structured transmission of data and documents between organizations by electronic means. Web-based applications. The third major area of today's extended EBS is comprised of a variety of customer and supplier-side software applications that are web-enabled and directly integrated with enterprise business system backbone applications. The first is business-to-consumer and customer relationship management. Utilizing the internet to sell directly to the customer has become one of today's top avenues for sales management. Customer relationship management applications enable companies to closely manage all aspects of a customer's relationship with an organization focused on increasing customer loyalty, retention, and profitability. CRM toolsets provide an integrated view of customer data and interactions, allowing sales and marketing to be more responsive to customer needs. Collaborative Product Commerce, or CPC. This can be defined as the enablement through web-based tools of virtual communities of manufacturing and product designers focused on new product development. Because it is internet-empowered, CPC permits companies to focus more intensely on their core capabilities while leveraging external design partnerships to dramatically decrease the time to market of product configuration and product rollout. Manufacturing execution systems. These systems manage and monitor work-in-process data, including manual or automatic labor and production reporting, online inquiries, and links to tasks that take place on the production floor. Supply chain management applications. These applications enable not just companies but whole supply networks to be closely integrated. Supply chain management applications encompass all operations within the supply chain, including the sourcing, acquisition, and storage of inventories, scheduling and management of work in progress, and the warehousing and distribution of finished goods. Supply chain management solutions enable businesses to streamline and automate the planning, execution, and control of these activities. Additionally, since there are often many third parties involved in a supply chain management software is designed to enhance communication, collaboration, and coordination with suppliers, transportation and shipping companies, intermediaries, and other parties. Internet-enabled supply chain management provides for the synchronization of the supply channel community, minimization of channel costs, optimization of network capabilities, real-time connectivity of channel supply and demand, and instantaneous visibility to demand and supply conditions within the entire supply chain network. Business intelligence. This comprises performance management and data warehouse software platforms. This software is used to access, transform, store, analyze, model, deliver, and track information to enable fact-based decision-making and extend accountability by providing all decision-makers with timely and relevant information. Business-to-business and supplier relationship management. Much has already been discussed about the content of business-to-business web-based applications. Tools in this part of the extended EBS application suite are focused on deploying independent, private, and consortia exchanges to facilitate materials and finished goods acquisition, requisitioning, sourcing, contracting, ordering, and payment utilizing online catalogs, contracts, point of sale, and shipping notices. Finance and human resources. The utilization of Internet technologies to facilitate financial and HR functions is a developing element in assisting companies to build competitive advantage in today's complex global business environment. Electronic finance focuses on embedding core banking services such as invoicing and payment, financing and risk management within purchasing and logistics functions. In the area of HR, companies are expected to make much greater use of online tools to assist employees populate and access personnel databases, such as human skills, repositories, recruiting, hiring, compensation, payroll and knowledge management solutions, housing the expertise and best practices of an entire corporate culture. And last are the portals. Portal technologies are designed to provide company personnel and trading partners with secure, personalized access to data and self-service applications, enabling them to react to changes in production schedules, forecasts, and other information. Usually, information is accessed through web browsers. The data retrieved is normally static and there is no direct access to the stored data. In next lecture, we will continue with the networking and integration frameworks for enterprise business systems. Now let's continue with the enterprise business systems networking and integration. The EBS application model we'll look through in the previous lecture implies that the range of EBS resident memory PCs and Internet-enabled applications are integrated together so that information and business process flow freely from any one place in the network supply chain to any other place. In greater detail, the model assumes that internally companies have accessible synchronized repositories of data about customers, processes, and products that transcend the boundaries of departments, divisions, and geographical units. The model likewise assumes that externally, customers and suppliers have the ability to traverse company-centric silos to tap seamlessly into information or generate transactions anywhere in the supply chain. Such a vision requires cross-functional integration, linking applications and data across business units, operating systems, and hardware platforms. Networking framework tasks. While the benefits of networking are tremendous, actually executing an effective comprehensive strategy for both external business-to-business and internal EBS integration is a complex matter. Companies often spend more on integration-related projects than needed because they are implementing point solutions without understanding the full breadth and scope of their broader integration needs. To meet this integration challenge, here are some critical issues that will need to be addressed. Evaluation of the capabilities of the existing integration toolsets and comparison to a list of current and future business needs must be performed. it is imperative that the following components are considered: enterprise application integration, business to business, business process management, and MFT. Integration standards must be available for document formats that enable the transfer of information between different business systems. Automated and standard transformation and routing tools must be available to convert and transmit data in varying formats and be compatible with existing investments in systems, transport, and business document formats. Tools needed to create and manage distributed business processes and documents exchange must be implemented. Strong security must be implemented that allows the data transfer to be encrypted and digitally signed. The integration tools must leverage standard Internet transmission protocols, as well as open data formats to facilitate data transfer between companies. The integration tools must be cost-effective for small as well as large companies to enable mass-market business-to-business transaction and trading. In responding to such a formidable list of requirements, it is critical that companies develop an integration framework strategy. Such a strategy enables companies to implement scalable integration capabilities that provide system designers with the ability to partition the business process logic found across application programs and arrange the collaboration framework needed to meet the functional requirements. At the heart of the integration architecture can be found a broad set of technology functions that has been termed middleware. The role of middleware is to coordinate and enable applications running on one computer to communicate with applications residing on another one. Middleware provides an e-business structure to access legacy systems, EBS as data structures, data warehouses, a repository containing a meta-model of the overall environment, and business-to-business interface points that constitute the range of network applications. Middleware provides the engine that enables internal and external business functions to pass data between each other. Middleware fall into two categories. Data-oriented middleware. In this category, middleware facilitates the sharing of information between different applications, such as a CRM system and an EBS. Process-oriented middleware. This category of middleware enables the processing and integrity of transactions and ensures systems integrity. Both categories can reside on a server embedded into one of many application layers. Functionally, when a transaction occurs in an application like e-procurement, the data passes through to the middleware layer where it is translated into a common language by any one of a number of middleware tools such as HTML or Java. Following, the data are then passed a readable format into another application layer, say the purchasing application inside of an EBS. As e-business collaborative commerce has expanded, the requirement for more complex connectivity tools that can not only pass data but also facilitate process-oriented business workflows has increased. Organized around the term business process management, this subset of middleware is focused on integrating business processes across business units, applications, and enterprises. The goal is simple. How can companies align business processes to deliver key information and performance indicators as opposed to just moving data back and forth? Through modeling tools that enable the creation of process via dynamic graphical environment, business process management provides visibility to business processes that span many types of computer systems, and architectures to assist managers monitor, measure, and resolve web-enabled processes throughout an e-business environment. The area of possible core and secondary functions constitute the structure of today's CBS is very wide. In reality, not all companies utilize all of these functions. As such, today's CBS must be capable of being configured to meet the information solution requirements of various types of companies. We will explore the two most common EBS types for manufacturers and distributions. In this lecture, ERP, and in the next one, supply chain and distribution. Enterprise resource planning. A common software system that has been applied by companies for many decades to manage their businesses is ERP. Historically, the value of ERP systems can be found in their ability to serve as a foundation for information and process integration and collaboration between company departments. Achieving competitive advantage requires all units of the organization to work together toward a common goal. ERP assists in achieving this objective by providing a central database that collects information from one and feeds information into all of the functional applications areas, so that effective transaction management, shared management reporting, and decision-making can be effectively performed. Beyond these integrative characteristics, an ERP system must also possess the following architectural elements. Flexible. ERP system architecture should provide the user with the ability to enable those application functions that constitute its business. The capability for complex system configurability is a significant enhancement of today's ERP over past systems, which were both rigid and monolithic and difficult and expensive to customize. Modular and open. Today's ERP system should have an open architecture permitting any module to be interactive with any other module without affecting system functions. This also means that modules can be enabled or disabled with impairing system integrity. An open system means that the software can be run on multiple hardware platforms. This feature is particularly important for businesses that have multiple systems and third-party point solutions. Comprehensive. The ERP system should support as wide a variety of organizational functions as is possible and support a wide range of business verticals. Networked. The ERP system should possess functionality that allows users to escape beyond the four walls of the enterprise by possessing internet connectivity to network them with supply chain partners. Here is an illustration of the functions of a typical ERP system. The architecture of an ERP system attempts to integrate all of the information processes of the enterprise and use the resulting synergy of planning and control enabled by this integration to continuously improve performance to the customer as well as establish uniform policies and practices across the business. An ERP system can be best understood by dividing the figure into three regions. In Region 1 can be found applications used for the development and disaggregation of top management plans, governing the overall direction of the enterprise, products and market programs, sales and promotions campaigns and aggregate product family priority, and resource capacity planning. Region 2 is composed of applications for demand management encompassing forecasting finished goods, order management, order promising and managing, intercompany channel demand, and inventory replenishment priority and capacity planning. In Region 3 can be found applications focused on operations execution, activities such as purchasing, production activity control, transportation and shipping, fixed asset and human resource management, and financial accounting. Now let's continue with the EBS architecture for supply chain management. One of the most crucial aspects of an EBS is its ability to adapt to different supply chain environments. For many software suppliers, the actual difference between ERP and supply chain management systems is negligible. For example, some software vendors include manufacturing planning and shop floor management as part of their supply chain management solutions. These major vendors have simply expanded their ERP packages to include supply chain management functions such as CRM, warehouse and transportation, and e-business, and then provided users with the ability to configure the exact EBS solution needed. There are, however, some other vendors whose software contains modules only for demand planning and forecasting, inventory optimization, order lifecycle management, transportation, and distribution. The standard module configuration of a supply chain management solution is shown in this figure. This model illustrates the integrative, interactive, and closed-loop nature of the typical activities occurring within a distribution enterprise. Similar to the general ERP model, the supply chain management applications presents a systemic approach. The flow of information begins with business planning, functions, and proceeds through operations and financial execution, and concludes with performance measurement. Besides providing a system approach to directing and measuring the entire enterprise, from internal functions to the management of supply channels, the supply chain management model provides a solution to the following problems plaguing the distributor. The creation of business plans addressing the strategic decisions defining enterprise mission, market demand, and the allocation of financial, physical assets, and human resources, and the mechanism to disaggregate those plans through logistics resource planning, supply chain capacity, and distribution requirements planning. The goal is the generation of time-phased plans where the demands of the entire supply chain are balanced against individual enterprise and total channel inventory, value-added processing, logistics, and purchasing capabilities. The capability to be agile and flexible enough to respond to the many changes occurring in the business environment by providing visibility to customer demand and real-time status of the supply chain. Changes in market demand, supplier delivery problems, excess inventories, inventory channel imbalances, marketing promotions, and a host of other events are made visible along with the mechanism to adjust and reallocate critical resources. By applying the time-phased logic of MRP and the ability to structure an integrated channel planning mechanisms through the bill of distribution, the supply chain management model provides planners with a detailed workbench to keep channel inventories low and evenly distributed to meet the demands placed on each channel node, while providing the tools to resupply the supply chain as efficiently and cost-effectively as possible. Supply chain management architecture also enables the design of performance measurement programs that look beyond local agendas to how well each channel segment is supporting the overall business plan. And finally, when integrated with today's new supply chain event management and collaborative forecasting and planning toolsets, the supply chain management model provides a catalyst for the application of internet-based technologies and lean principles targeted at removing barriers to time and space as well as to quality and excellence. Supply chain management software solutions offer distribution functionals a fresh approach to running the supply chain that is fully compatible with today's newest web-based technologies. Both as a management philosophy and as a suite of integrated business applications, supply chain management software permits distribution companies to synchronize demand and supply up and down the channel network and link their systems with the core and secondary EBS functions of supply chain partners. Such an approach enables entire supply chains to compete as if they were a single, seamless entity focused on channel cost reduction and superior customer service. Considering the opportunities and the risks of implementing an EBS solution, executives need to have a well-defined strategy that includes both system selection as well as objectives to be attained. Executives today have 5 alternatives before them when choosing an EBS solution. Deciding on an option is governed by several factors including length of implementation time, cost, flexibility and complexity of software, quality of the solution, fit to the enterprise and intensity of staffing training. The first solution is build. In this option, a company decides to build its own EBS. In the past, this option was distinctly unfavorable, but with today's new composite application tools or by engaging an inexpensive, high-quality third-party developer, this option has become viable, especially among many non-manufacturing organizations. Buy. Today, this approach is the most common. According to a recent survey, there are available more than 52 ERP supply chain management software products from more than 30 vendors, and there are many more out there with new ERP software packages, ERP add-ons, and utilities appearing regularly. Best of breed. This option consists in acquiring highly specialized point solution, for example transportation management system, and then interfacing it with existing systems. The advantage is that a point solution contains significant depth and agility to handle a special business problem than what is available in a standard EBS. The disadvantages center on implementation and integration costs, upgrade maintenance, and risk of vendor viability. Rent. In this approach, a company does not own the software but rather rents it via hosting or an alternative provider. Today, the emergence of new players and the growth of software as a service have made this option more attractive. This option enables companies to minimize risk, cut costs associated with IT staffing, leverage deployment flexibility, and enjoy speedy use of the application functionality without long implementation timeframes. Last option, outsource. Some companies have decided to let service suppliers run key processes for them via business process outsourcing or strategic outsourcing. The goal is to eliminate the cost of IT equipment and overhead. This option is often pursued by very small companies with limited capitalization. Regardless of the option selected, there are 10 major criteria that should be referenced when selecting a software system. Here they are: functionality, the area of resident applications and their level of fit to company business processes. Ease of use, the speed by which users can overcome the functional learning curve and the transparency of the applications relative to company processes. Performance, the processing speed by which data can be entered, calculated, maintained, and retrieved. Scalability, the ability of the user to enable or disable software modules during implementation and as the company's demands on the software expand. Interoperability, the ease with which the software can be interfaced, integrated, or networked to other software systems. Extensibility, the ease with which modifications or software enhancements can be made to the base software product. Stability and reliability, the software's basic data integrity and freedom from bugs or invalid calculations. Security, capability of restricting access to users, groups of users, or outside the organization partners and customers. Support, the quality of implementation assistance, ongoing consulting, documentation, and training. Vendor viability, financial strength of the vendor organization to provide periodic system enhancements and ongoing support and services. To ensure effective due diligence, executives need to ensure a match between the needs of the business and the technical solutions available.